All right, guys. Hi. Okay. Miss Howell here, in case you don't know me. I'm one of the other math teachers here at Mayport, and just so you know, I'm going to be helping out with Miss classes until you guys get your new teacher back. So, um, hopefully this helps. Again, I know some of you don't know me. That's okay, and some of you've had me before, so you know how I roll. Okay. I do want to put out a little bit of like a disclaimer here. Um, I know Mr. Wang offered tutoring and stuff when he was there. And obviously he's not there, so he's tutoring. But if you guys need any help, I do tutoring on Tuesdays after school until 5:30. You are more than welcome to come. If that day doesn't work for you, Miss Brown, she's our other 8th grade math teacher. She does tutoring almost every day after school. My only suggestion or slash like request is like email her or like drop by and see her. Her classroom's in the island. She's right next door to Miss Garvey. Right before you get to Miss Howard, so she's in between the two. Um, Ask her if she's having tutoring after school because some days she's got stuff after school, so she can't stay. So if you need help, you can come to me on Tuesdays after school, or you can go see Miss Brown on pretty much any day that she's free. Okay, so just make sure you check in with her first if you need some extra help. Okay, or if you can never, you just can't stay after school because you ride a bus or whatever, you can just email me. You should be able to just like click on my name on Focus because I should be added as one of your teachers. And you can just email me that way. Otherwise, it's HOWELLL, the number one, at duvalschools.org. And that's my email address. You guys need help on something, okay? All right, so we are going to be looking at 5-5, which is where you have to sketch functions from verbal descriptions. Basically, they're going to give you graphs that look like this. Um, and you have to tell me what happened, or they're going to give you a paragraph and you have to make the graph that's kind of like this. Okay? So that's what you got to do. So first, let's make sure we know some of our vocab. Okay? So whenever we have the independent variable, okay, hopefully you know whenever you see independent variable, that's whatever the x or the x value, whatever you want to call it, okay, or the input. Okay, so on the graph, that's going to be the part that's on the bottom, side to side. So your dependent variable, that's going to be your y value, y variable. Going to be the one that goes up and down on the graph. Okay, so like here, it's labeled for you. Okay, it won't always be labeled for you, so you need to know that which one's which. Okay, so again, the x variable is the one that goes left to right. The y variable is the one that goes up and down. Independent x, dependent y. You kind of want to think of it as the independent one. That's the one where no matter what, it's not gonna change. It is independent. No matter what you're doing, nothing gonna change it. Like usually, independent would be something like time, because like you can't change time. Time is just time. Okay, it keeps going by no matter what happens. Okay, whereas dependent is something that changes over time. So like how much food you eat in a day. Okay, over the time of the day you're gonna eat more food, right? Because you start off with breakfast, then you have lunch, then you have dinner. Like you're increasing the amount of food that you eat today, or throughout the day. Okay, that would be the dependent variables. How much food you eat over the course of a day. I hope that makes sense. That was the first thing that just popped in my head to explain that. So hopefully that works. All right. Next one, increasing. Hopefully you know increasing means that graph goes up. Graph goes up. Okay, so that's increasing. Okay, graph goes up. Okay, normally it's gonna go up, so it'll tell you how fast it's going. So if it says that it's increasing, um, like at a kind of like a medium number, it'll increase like a little bit. Or if it's increasing steadily, When it says increasing steadily, that means it goes up in a straight line like this. That's increasing steadily. So that would be like going, like, it's kind of like speed. So speed is like, 30 miles an hour, 55 miles an hour. You're going that speed the entire time. So you just keep going up, 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 up at that speed. It doesn't change. There's going to be other times where it'll say it increases drastically, or it'll increase more quickly or faster, whatever it is. So whenever it says something like it's going to go faster over time, that means that your line is going to need to go more up. Okay. It's going to be more angled to the left. Okay, going up. See how my first one is kind of angled more downwards and this one's angled more upwards? That's the difference. Okay. All right, so let's look at decreasing. Decreasing means that your graph goes, what's the opposite of up? Yeah, there you go. So this time your graph goes down. Okay. So again, it's going to be, if it says it's steadily, messed up my picture. So if it says that it's steadily decreasing, that means it's going to go down slowly over time. So it's just going to go down like a little bit, okay? Whereas like if it says that it's going down drastically, or it's increasing its speed, or like decreasing its speed quickly, or like say you're in a car and you have to stop really fast because cars do that, or maybe you didn't notice it was going to be a red light or something, so you have to stop really fast. So if you have to stop really fast, that means your speed has to go from like, I don't know, say like 30 miles an hour, 0. Gotta go down super fast. So again, it's just a little bit of a change to like steadily increasing or steadily decreasing. You see how it's going down just like a little bit, but then if you have to go super fast, you change it so it's pointing more down. It almost looks more like a straight line going down. That's kind of like the difference that you're looking for. Okay, now the last one, constant. This is the easy one. Constant means that it's not changing. Okay, so if you're not changing, okay, say you were at or I'm gonna read first. Don't forget. Say it's not changing or the same. Okay, so if something is not changing, that would be like say you're going the exact same speed on this place of road, on this road. You're going 30 miles an hour the entire time. You're not going to go up to 35, you're not going to go down to 20. You're just going at 30 miles an hour. Okay? So if you're at a constant rate, you're going to be just going straight across. Okay? You're just going straight across. Okay, that's constant. Another example of something constant would be if you have stopped. Okay, so because like if you stopped moving, you wouldn't be going up or down, right? Yeah. So normally they'll use constant like if you stopped moving and you're just like standing in one spot, not moving. Okay, that's when you would use that one. So that's some of like the basic vocabby stuff. Let's actually try some of these examples. See how we do. Okay, so these do not have to be perfect by any means. Just do your best. If you have your ID, that might help you draw some of like these straight lines so they're not going like, wibbly wobbly here. I'm gonna find my protractor. Protractor. Got it. Now we can draw straight lines. Alright, so let's try this first one. It says a scuba diver starts a dive. They start a dive with a full tank of oxygen. And so if you're starting with a full tank of oxygen, right? Would you have 0 oxygen or like all of the oxygen? What do you think? Let's see. So if it says that it's full, well, full is definitely not 0. Okay? Because if it's full, that means like, you have stuff in there, right? You got stuff. So if we have stuff in there, that means we should probably start off like up here. Okay. So that's going to be your full tank of oxygen. Okay. And then it says, while diving, she breathes at a constant rate. Okay. And it says that she checks the gauge after 22 minutes. What does a graph of the function look like? So, just out of curiosity, right? Just to make sure we're all on the same page. Whenever you are, if you're scuba diving, what happens is that you have like a big tank full of all the air that you have to breathe, you know, because you're underwater. And there's no air in the water that you can breathe. You can't just be like breathing in the water. It doesn't work. No. You have to have a tank of air. And the longer you're in the water, right? What happens to all that air in the tank? You're using it, right? So what's going to happen to that amount of oxygen, that amount of air that's in that tank? Would you have more air or would you have less? Think about it. You got to breathing it in, right? So if you're breathing in all that air, you should end with no air. You're gonna use it all. Hopefully you come up out of the surface before you use all of it. Otherwise, that might not end well. So, it says that what does the graph of the function look like? So let's see here. And we said if it's a constant rate. So when it's at a constant rate, it's not going to be like squiggly, right? Constant means that it's not changing, it stays the same. So that means I'm just going to draw a line down where it's just constantly going down at the same amount. Okay, there you go. Okay, now if you want to be fancy and label your graph, like 99% of the time, this bottom one will be time. And then the part on the side is whatever this person was using or doing. Okay, so this person, they were scuba diving and we were talking about how much air they had. So, or the oxygen. So you can say it's their oxygen level. So what does the graph of that function look like? It's going to decrease over time. If I could spell time, that'd be great. And yes, I write a little bit in cursive, so go with it. Okay. All right, now, if they ask you about it, I doubt it would be like on any of your like tests, like state tests or whatever. But just in case, if they asked you about the slope of this type of graph, okay, you have to ask yourself when you looked at the picture, right? When you started on the left side, what happened to your line? Did your line go up or did it go down? Hopefully you said it went down. So if it's going down, that means that it has a negative slope, okay? Because it was going down. All right, that's pretty much it. You're going to be doing that for the next like 4 questions. You're just drawing the graph for it, okay? All right, let's try the next one. It says the weight of the water exerts pressure on a diver. So again, we have another diver. It says at a depth of 10 feet, the water pressure is 19.1 pounds per square inch psi. And at a depth of 14 feet, the water pressure is 20.9 psi. Complete the statements and sketch the qualitative graph of this function. Okay, so this is the part where you got to figure out what goes where and which one it is. Okay. So let's see what we can figure out here. So again, we have another diver in the water, right? So you kind of want to look at the numbers, if you will. Okay. So we're starting off with a depth of 10 feet. And then we have the water pressure is 19.1 pound per square inch, or PSI. Okay, and then we went to 14 feet, and now the pressure is 20.9 PSI. So, what were the first numbers in each sentence? Right? So here's the start of my sentence. If I go, keep going. Here's my first number, 10 feet. So at 10 feet, it was 19.1 PSI, right? And then at 14 feet, we had PSI. So when we look at our variables, like independent or dependent, okay, you're looking for which one is not gonna change, like, no matter what you do to it. Like, if you think it's the pounds per square inch, think about it. Pounds per square inch, is that something that, like, never changes? Okay, like, you can't manipulate it. Okay, or is it how many feet you have? It's like, when you think about it, if you have 10 feet, so pretend this is my ruler, right? Pretend that this is 10 feet. Like, is there any way I could just, like, break this off and, like, just magically, like, change the numbers on it or something to make it not say this is 10 feet? Is there any way you do that? Could you change this to say, oh, this is 10 feet? Well, now it is magically 3 feet. Can you do that? Is that going to change? Hopefully you said no. Okay. It's not just going to magically change into something else. So that is going to be the feet. That's going to be our independent variable. So we're going to say, and we were at a depth. So this is the depth of the water. So if you want to say feet, or you can say depth of the water, or height of the water, however you want it. Are you guys tired? Like, I know you don't know this, but it's almost like 11 o'clock at night. And I am recording this for you. I should be in bed. Anyway. So, if the depth of the water is your independent, what has to be your dependent? Here's the big hint. Only thing that's left. So, what was the only thing that was left? That would be your PSI. Okay, that's going to be your dependent. That's the part that's changing, because when we were 10 feet, we were at 19.1. Then we were at 14 feet. What happened to your PSI? It went up. Okay, it changed. It depends on how far you are or how deep you are on the water, because the more you go down into the water, right, the more pressure you're going to feel on yourself. Okay, that's a dependent variable. Okay, so let's write that down so we can say the water pressure, or you can put PSI. It is your choice about how you want to do it, but those are the basics. Okay. All right, now we gotta do the graph for this. So again, we said that our independent or x variable was depth of the water, so I'm gonna label my graph with that. Depth of water, and that was in feet. And then we had water pressure, or PSI, for the y variable. All right, so if you want to get, like, fancy on here, if you want to try to number it, feel free, go ahead. A lot of these types of graphs don't really have numbers on them a lot. A lot of them are just, there's no numbers other than, like, 0. So you can just kind of, like, guesstimate it. It works. So we're just going to do that. So think about it. If we went to 10 feet and then is at 19.1 and then 14 feet was 20.9. What happened to both of your numbers? So like for the feet, we started with 10, ended at 14. So what happened to your numbers? They went up, right? They increased. What happened to your pressure, right? It went from 19.1 to 20.9. Did the numbers go up, numbers go down, or stay the same? Hopefully you said they increased or went up. So if we have increase, that means we're just going to start at 0. Because if you think about it, we're starting at 0 because, in case you were not aware of this is like a fun fact that you need to just like file away in your brain. 0 feet in water is sea level. Like that's the top of the water. Like if you're in a boat or whatever, that's the top of the water right there. Sea level is 0 feet. So if you're at 10 feet, you start at 0 feet and you're going down, okay? That you're increasing the amount of water that you're going into. Okay, so if we're increasing the amount of water we're going to, and then we're increasing the water pressure, we're going to start at 0. So if you started at sea level, and we're just going to be going up, okay? And because, let's see, where did they say? Okay. I was looking for the words if it was like a constant pressure or constant increasing amount, something like that. Okay. So, when you're trying to draw the line, ask yourself, did my numbers go up really fast or like kind of slowish? Or just like a medium? Okay. To go from 19 to 20, did you go up really fast? To go from 19 to 20? Hopefully you said no. Okay. They went up, what is it, 0.1, not even 1. Yeah. They went up like 1.8. Whoa. Okay, that's not much at all. So we're just gonna kind of draw our drops. Now, if my numbers went up a lot, I would make a really steep line like this if they went up super fast. So like if I went from like 10 to 800 or like 10 to 80, I would go up super fast, but we're not. We only went from 19 to 20. So we're gonna kind of draw it like this because this means we're going up slowly. So if it helps, if it goes straight up like this, that's going like super fast. This is just going kind of like eh, and this is going like slow. Okay. So I'm just gonna kind of put it here. And we were increasing. And there you go. There's your graph. All right, let's try this 3 more times. The next one's easier, I promise. Okay. All right, take a look at number 3. It says Danica sketched the relationship between altitude and time for one of her parasailing flights. Describe the behavior of the function in each interval based on her sketch. So, for Miss Danica, right? When you're looking at her graph, how many different like parts of the graph do you see? Okay. So again, look at that for a little bit more. How many parts of the graph do you see? Hopefully you said 3. Okay. So if you look at it, I'm gonna kind of highlight it a little bit. So markers of, see if this helps you figure it out. Okay. Let's see, we have this like this part right here. We're going up. Okay, right? And we have this part. There. Another part. And we have the pink. Then we have that part. Okay. So if you need to like do that on your papers or like on tests, whatever, to help you figure out how many different like sections of a graph you have, do it. Feel free. You get the highlighter tool when you're doing it online anyway. As well use it. Okay, so that can help you figure out how many different sections you got. So section number 1. So I'm just gonna label this. So this is 1, 2, 3, and then this way you can just write them over here. What's happening? So in part 1, what is happening with our graph? Let's see. Well, looks like it's going up, right? So let's see. Danica is talking about going parasailing. Okay. In case you don't know, parasailing, that's when you have like a big like parachute, but you're being pulled behind a boat. Okay. It's really cool. A little bit scary if you're afraid of heights. I got to do it one time when I was a kid. That I did not like the part where I could see the sharks in the water. That part was not okay. Traumatized. Anyway. But anyway, so for parasailing, again, you're in like a parachute and you're being pulled behind a boat. Okay? So let's see. If you think about it, how this would be, this is the time, and this part is the altitude. Okay? If you don't know, altitude is like the height, how far up she is. What number is this right here? Like I know it's super small, but you should be able to read the paper. This is 0. Okay. So this is where she started. So she's starting off like in the boat. Okay? Because that's where you start. You start in the boat. And then eventually the wind picks you up and you're gone. Well, not gone. You're still attached to the boat, but you knew what I meant. Okay? So this part, this is where Danica is like going up in the air. Okay, she's going up. So Danica. Hold to the air. Okay. All right, that's section 1. You don't have to phrase it like that. That's just I'm doing it. You say this is the part where Danica like gets off the boat and starts flying into the air. Okay, however you want to say it. Okay. Now, step 2, right? What do you notice about the line? Okay. This is like one of the vocabulary word things we went over. Which word does step 2 look like? Hopefully you said it looks like constant. Okay, it's not changing, it's the same because it's going straight across. So we can say for step 2 that Danica is parasailing at a constant speed. So in other words, the boat is going like, I don't know, 20 knots. However, I don't know. Yeah, I think that's what they use. Anyway, so we're just gonna pretend that it's like miles per hour. Speed. Okay, it's going 20 knots per hour or 20 knots. 20 miles per hour. That's how fast it's going. And it's just chugging along. We're just gonna keep going 20. Okay. That's what step 2 is. You're going the exact same speed no matter what. Okay. That's step 2. Okay, now step 3. Well, this is the fun part. Okay. What's happening in step 3? It's going okay. This is the part where Danica is going to be dropping. Okay, she's going goes down. Okay, because that's literally what happens is the boat slows down so that you don't have as much air going into your like parachute thing, and then you just fall into the water. That's what happens. So you're just like, oh, we're going down into the water. That's what happens. Sad. It's a little traumatizing, a little bit, but I think it was fun. But maybe not when I'm anyway. So step 3. So we're gonna say this is where Danica. You can say this is the part where Danica's parasailing, or Derica's Danica. Why did I say Danica? This is the part where Danica's parasail slowed down and stopped, and she fell into the water, or Danica's parasail stopped in the water, or Danica lost speed and dropped down into the water. However you want to describe it, but that's basically what's happening. You just talk about how Danica is losing speed, dropping into the water, and stopping, something like this. This is how the book said it. They said that Danica is dropping down to the water. Okay. Alright, here you go. That's what happened. Alright, number 3. Okay. Let's look at number 3. Number 3 says Jose is practicing javelin throws. What is the relationship between the height of the javelin and time? And what would the graph of this function look like? So, first of all, let's see. If you don't know, like, imagine yourself just throwing something, right? What is the relationship between the height of whatever you're throwing and time? So if you throw something, okay? So if you like throw it, what happens when you throw something? Like when you first throw it, like did the thing go up or does thing go down? Or does thing magically float in the air at the same spot? Hopefully you said the thing went up. But then eventually, what happens to anything that you throw? It does what? It goes down. Okay? It falls down to, like, it'll fall down into, like, if you're throwing a ball into the person's hand, it'll fall down into, so you're shooting a basket, it'll fall into the basket, wherever you threw it. It's gotta fall down somewhere. It's gotta land somewhere. Even if you're throwing a paper airplane, okay? Throw that paper airplane up, it's gonna go up, but then eventually it's gonna go down, okay? So it happens to anything that you throw, okay? So the relationship between the height of the javelin and time would be that when he first throws the javelin, right? What happens? Does javelin go up or javelin go down? Okay. Let's see. Again, on your graphs, time is going to be on the bottom. So in case you haven't noticed a pattern here, let's take a look. Hey, look, what's on the bottom? Time. What's on the bottom? Time. What's on the bottom? Time. Oh, look, what's on the bottom? Depth of water. It's something you can measure for all of them. It's either time or like height or something like fun fact. Keep that in your brain. Get it later. Okay. Good. All right. So we had time, and then we were looking at the height of the javelin. Okay. So you can just say height. Okay. All right. So let's see. When you're throwing something, okay, I want you to imagine, right? When you throw something, are you like laying on the floor throwing something, or are you normally like standing up? Like if you're playing basketball, right? Do you lay down on the ground and just throw a basketball? Is that how you play? I'm gonna hope you all said no. I mean, if you said yes, I have questions. A lot of questions. So hopefully you said no. Okay. So this is gonna play like for our height. We have to start at like here-ish. Okay. Because that's how tall Jose is. Okay. Because he's gonna throw it like, up. You're throwing a javelin. Like this is kind of, there you go. Throw it like that. Not but you know what I mean, right? You're throwing it at his height. Okay, or about his height. You're not throwing it, down here on the ground. Not how it works. Okay. In case you couldn't tell yet, I'm a very expressive person. So that's just how I am. So I'm sorry if it doesn't translate into videos. But anyway, so we're throwing the javelin. We're gonna throw it at our height. We're not gonna throw it down on the floor because that wouldn't make sense. Doesn't make sense. So we're gonna throw it up here, right? And this graph doesn't have to be perfect. Again, you're just kind of like estimating it. So we said when we throw that javelin, it's gonna go up for a little bit, and then eventually, what happens to everything? It's going to go down. Okay. So if you need to like extend your graph a little bit, that's totally fine. Okay. So javelin went up a little bit and then javelin goes down. Okay. So that's what our graph would look like. So the relationship between the height of the javelin and time. So we could say for that part, when Jose first throws the javelin, it's increasing, or you can say its height increases, or it's going up, however you want to say. When Jose first throws the javelin, it's increases. One thing I do want to show you, we haven't talked about this in other ones. So if you're throwing something, you see this part right here. Okay, so mostly like this part right here. That would be the that's the maximum. Okay, that's as high as that javelin is gonna get, right? It didn't get higher anywhere else. It didn't just go like woo. It didn't do that. Okay. So this is called your maximum height. So when Jose first throws a javelin, its height increases. And after it, or after the javelin is maximum height, it starts to go down. The speed decreases, height decreases. How you the what? What does it reach? Okay, so think about it. When you throw something, it's gonna go up, it's gonna reach the highest maximum point, and then it falls to the what? Falls to the ground. Okay, so make sure you put it reaches the ground. It falls down. All right. So one more question. I know I babbled a lot, but it's Miss Owl for you. Plus it's late. All right. So this one's gonna be a fun one. Kind of. Okay, it says Haru. Okay, I'm hoping I'm. If I'm not, I'm sorry. Haru rides his bike from his home for 30 minutes at a fast pace. Okay. So this is your keyword right here, fast pace. So we kind of talked about that at the very beginning of this, fast pace. Is that increasing, decreasing, or you're going at a fast pace? Hopefully you said increasing. And remember when we talked about these, which one would mean that you're going faster? Would it be the first arrow or the second? Hopefully you said the second arrow. Okay, we're increasing fast. That means our line is gonna go up like boom, like gonna go up like this, super fast. Okay. So if you want to write yourself a little reminder of what that's gonna look like, go. And then it stops to rest for 20 minutes. So if you're resting, are you moving? Like normally, like if you're riding a bike and you took a rest, is your bike still moving? Hopefully you said no. Okay. Not moving. So if it's not moving, that is going to be a straight line. It's going to be constant because you're not moving. And then it continues in the same direction at a slower pace. Oh, that was a terrible. Slower pace for 30 minutes. So if you're going slower, right? You're still going up, right? Still going up. But would we be going up like a lot, like or just kind of like like I'm tired, let's go, but I don't want to, or you're like, yeah, let's go. Hopefully it says that first one where you're just going like I can kind of go, but it hurts. So for this one we're just gonna go up, but just like a little bit here. Okay. So that one. Now we're just gonna put all that together. Okay. So if you want to, you can use like these little tick marks to be like your time frame. Because this bottom part, again, I know you're shocked by this, but it's going to be time on the bottom. Okay. And then the next one is going to be, we're talking about riding his bike. So that's going to be distance. So it's going to be distance. All right, so we're going to start at 0. So we're going super fast first. So super fast means that we're going to go like straight up. So, straight up, just like that. Okay. And then it says that we had a rest for 20 minutes. So rest we said was constant. So we're going to go straight across. That to make straight. We're going to go straight for like 20 minutes. And then it said that we're still going to increase, like, but we're going to go slower this time. So we're not going to go this same slant. We're going to change it to be like that. Okay, so we want it to be slower. Okay. And there you go. Okay, that is what that graph would look like. Okay. All right, so here you go. Your homework, pages 282 and 284. Unfortunately, for some reason, I don't know why, I don't have access to Savas online for you, so I can't just assign it for you to do on the computer. You have to do it on paper, so that's why I'm going to print you out copies of it. So please ask Ms. North. She will have those for you. Okay. And that's your homework. Okay. So normally for me, what I do is I grade your homework based on correctness. Okay. It's not a completion grade. I am grading it on did you get the questions right or wrong. Okay. So please be aware of that when you're doing this. And make sure you take the time to try to do it correctly. Okay. You get 1 week for every assignment for me. Okay. So that means if you're getting this assignment, this should be like on Thursday or Friday of this week. You have until Thursday or Friday of next week to turn it in, whatever day you have me. Okay. Or have math. But technically it won't be. But that's how this is going to work. Okay. So make sure you're trying it. This is up to Miss North. If you can work with a buddy to do it. If she says it's okay, I don't mind it. As long as you are behaving yourselves. Okay? So again, you need to make sure you do those pages and do them correctly. Okay? And again, if you get stuck, you can email me, or I have tutoring on Tuesdays after school, or you can go see Miss Brown. Just talk to Miss Brown first or send her an email. This way she knows if you're coming. Okay? Otherwise, till next time. Bye.